Alright, this is 8.1, Similar Polygons. The central question will be how are similar polygons related? What you're expected to learn on this lesson is to use similarity statements, find corresponding lengths in similar polygons. We're also going to talk about finding perimeters and areas of similar polygons, and then we're going to decide whether polygons are similar. Alright, so similarity statements, that's what this is right here. The triangle RST is similar to triangle XYZ. This little wave here, this tilde, that's the symbol for similar. That's how you know what it's talking about. So similar. Right? Now, if you have two shapes that are similar, what that means is that the angles are the same. So I would know that angle T is congruent to angle Z. R would be congruent to X, and S would be congruent to angle Y. So the angles match up, and the order matters. So you know R would correspond to X, S would correspond to Y, and T would correspond to Z. Okay? But since they're similar, that means that their sides are not equal. So if I had to say this was 25, this would be 20, and this was 30. Okay? Then on this other shape, I know that these numbers are going to be different, but yet they're going to be what's called proportional to the other sides. Okay, so let's put some numbers here. Let's say this is 15, this is 12, and this would be 18. Now, because they're proportional, what that means is that I could set up some ratios. So RS over XZ, right? So that's the 20, or excuse me, RS over XY, that's 20 over 12. If I did it that way, so RS and XY, that's 20 over 12. Okay. If I take any other two sides, or actually we'll do this for all three of them, but let me back up. If I reduce this, divide by 4, that's going to give me 5/3. So if I take, say, ST, which is 30, so I'm going to do ST over YZ, that's going to be 30 over 18. If I reduce that in lowest terms, I'm going to get also 5/3. Right. And then if I do, see, RT would be the third side, and XZ. Okay, so that's going to be 25 over 15. And if I divide both sides by 5, I'm going to get 5/3. So notice that each of these is the same. Right, so that's what similar means. The angles are the same, they're congruent, and the sides are proportional. They have the same ratio. If I were to take the corresponding sides, okay, and simplify the units, the distances, I would get the same ratio for every side, corresponding side pair. Okay, so now let's look at a problem that has a side that's missing. Because they are similar, I know I can set up those ratios, the proportion to solve for X. Because what I can do is I can take any, since I have all three sides labeled, I can just pick two pairs. Let's do the 20 and 24. And so I know 20 is to 24 as X would be to 30. Okay. Now, what you would do, if you remember, you can do cross products here. So you'd have 20 times 30 is equal to 24 times X. Okay. So this would come out to be 600 is equal to 24X. Divide both sides by 24. And you would get that X is going to be 25. Okay. Another thing that you can do, another strategy, right here at the beginning, if you can take 20 and 24 and you want to reduce that in lowest terms, it's going to make the math, the calculation stuff easier. So here I can take out 4 out of each one, and that's going to give me 5/6. Okay. I can't factor that anymore, so if I go up here and I have 5/6 is equal to X and 30, 5 times 30 is 150 equal to 6X. If you're not using a calculator, the math comes a little easier here. I know that I could do that. That goes in twice. That's 12, that's 30. 630 goes 5 times. Okay, same answer. It might make your numbers a little smaller, or it will make your numbers a little smaller. The math will be a little easier if you reduce at the beginning. All right, on this example, it says in the diagram, triangle TPR is similar to triangle XPZ. We want to find the length of the altitude of segment PS. So this right here is the altitude. All right, and I know that is because it's going from the vertex to the opposite side at a 90-degree angle. So that would be altitude. Remember that altitude is another word for height. Okay. Now, the thing to remember with this is that if the triangles are similar, the altitude or the heights are also similar. So what I would do first is I'm going to go ahead and take this TR right here, make that 12. I'm going to add the 6 and the 6. Same thing with XZ. 8 and 8 would be 16. Okay. So, and I'm going to make my altitude, I'll make that my X. Okay, so I know I'm going to have, let's see, 12 is to 16 as X is to 20. Okay, notice that I started on this smaller triangle for the 12 to 16. So when I make this other ratio, I'm going to start with the small triangle over the big triangle. So again, I'm going to reduce this just to make my numbers easier since I'm not using a calculator. I can divide this by 4. To reduce, it's going to give me 3/4 X over 20. So that means this is 60. I cross multiply 4X. And then if I divide both sides by 4, I know that X is going to be 15. Okay, so my altitude, the length of PS is going to be 15 units. So now what we're going to do on this is we're going to look at the perimeter of similar polygons and see what happens, see if there's any conclusions we can make. So if I just look at the sides here, I know this is 18, and this means this has to be, RS has to be 18. So if I'm looking at just a ratio from RS to AB, and I know that's going to be 18 over 9, which is just a 2-to-1 ratio. Okay. Now what I'm going to do is I'm going to look at the perimeter of segment of RSTU, okay, which means I have to add up all my sides. So 18 plus 18 plus 12 plus 12. Okay, that's going to come out to be 60. Okay. Now if I take the perimeter of this other rectangle, ABCD, and I add up all my sides, that'll be 9 plus 9 plus 6 plus 6, and that ends up being 30. All right, so if I take the perimeters, the ratio of the perimeters, perimeter over perimeter, that's going to be 60 over 30, which is also 2-to-1. Okay, so these are equal. So the thing to remember on the perimeters of similar polygons is that the ratio is equal to the ratio of the corresponding sides. Okay, for this problem, what we're doing now is we're going to look at area. What happens to the area of similar polygons? So we want to use this to find the area of triangle DEF. Now, it's slightly different from perimeter because it's not the same. The ratio of the areas is not equal to the ratio of the sides. What ends up happening on this is that since area is in square units, it's got to know how to remember it. I'm going to have to take the ratio of the sides. So I know 10 over 5. Okay, that's the ratio of the sides. That's not necessarily equal to 36 over the missing area, which is triangle DEF. I'm going to put that as an X. Okay. What I have to do to this ratio is I have to square it, okay, before I solve it. The ratio, that's the difference between perimeter and area. The ratio of the areas is squared the area of the sides. So if I square this out, that's going to give me 100 over 25 is equal to 36 over x. So I got 100x is equal to 25 times 36 is 900. Okay. Now I divide both sides by 100. And that tells me that x is 9. X was my area, so I know that the area of triangle DEF is 9 centimeters squared.